Oh my gosh, did you see that happen at the same time that I did? Well, that's how light works. And this is how gravity works. I'm Kate, and I'm here to explain the theory of relativity. Einstein's theory drastically changed the way that we think about physics, but it all started in 1687 when Newton published his law of universal gravitation. From there, Einstein stopped to discover what Newton didn't talk about. What about acceleration? How does gravity affect light? Where does gravity even come from? And how does that affect how we see things here on Earth? Which brings us to the theory of special relativity. In 1905, Einstein published his first theory of relativity, which stated that the speed of light is the same throughout the universe and that physics affected all non-moving observers the same way. Because he realized that space and time were interwoven in a plane known as space-time, his ideas about special relativity meant that two observers could see the same action happen in the same place at two completely different times. In this case, those observers are my cats.
Imagine 3 points, A, B, and C. When I pour food into the bowl at point A, the cat at point C will see it happen before the cat at point B, because point C is closer to the food bowl than point B, and the speed of light is constant for both observers. Even though they saw the food being poured at different times, they are both right about when it precisely happened.
The theory of general relativity, published in 1915, was built upon the cause of gravity. Once Einstein figured that out, with a little help from the principle of equivalence, everything else about its effects on light and acceleration fell into place. Because Einstein knew that a free-falling observer would accelerate at a constant rate because as the distance between two masses decreases, the pull of gravity increases, he knew that an observer wouldn't be able to tell the difference between free-falling and artificial acceleration caused by something like a rocket. Hence the name, the principle of equivalence, because the effects of gravity and inertia feel the same. Because Einstein knew that acceleration was the movement of an object through space, and that the effects of gravity and inertia feel the same, that meant that any changes felt while accelerating in an object or observer weren't actually happening within themselves, but rather in the space around them. Because of this, he knew that gravity was caused by the dips in the plane of space-time. Once he realized this, he was able to bring light into the equation, because light travels along the same plane as matter, so therefore it would also be affected by gravity.
If space-time can be equated to a pond and a rock to a planet, dropping the rock into the pond creates ripples in the water. These ripples represent a gravitational field. If you look, you will see how the ripples in the pond distort your reflection. The ripples disrupting the surrounding area of the rock show how light or matter can no longer travel straight because the plane they travel in has been disrupted.